I don't know. I'm sorry.
Okay, today we start functions. Now I know this is all review from last year. And pretty much everything we do in the first semester here is review. What's going to happen second semester when lots of the topics we cover are not review? What's going to happen?
Go home, cook
We're gonna score better.
There's gonna, I don't know, to me the solution is simple. Do your homework every day. That's all it is, man. Okay, today we're doing functions. Now, the first worksheet is basically the nuts and bolts of functions, like finding the domain, finding the range. Is the function odd or even? Does that sound familiar? You guys never heard of odd and even functions?
It's not when you plug in like the negative x and the negative
Yeah, come on, this is all review. Okay, let's start from the very beginning. First of all, do we even know what a function is even? Okay, wait, let me ask you some questions. I'm gonna ask you some questions. Okay,
There's only one.
what is a set, what is a set of ordered pairs called? Like, you draw any graph. Whoa! What is this? Is this a function?
No.
No, it's not a function. What do we call it then? What do you call a set of ordered pairs, or basically any graph? This is called a relation. However, if your relation passes the vertical line test, in other words, for every x value there's only at most one y value, we call that a function. It passes the vertical line test. And if it passes both the vertical and the horizontal line tests, we call that a one-to-one function. Now is it all coming back like a bad dream? So like, for example, a quadratic function like this. Well, is it a function? Yeah, well, I just called it a function, yes? Because every vertical line you draw will intersect the graph at most once, right? Is this a one-to-one function? No, because it doesn't pass the horizontal line test, because look, I draw a horizontal line that intersects the graph twice. So can you give me an example of a one-to-one function?
Well,
Yeah, but that's weak. How about y equal x cubed? Right? It passes both the vertical and the horizontal line test. That would be a one-to-one function. So those are three terms you need to know. Relation, function, one-to-one function. It's all coming back. Now, what is an even function? By definition, f of negative x equals f of x. In other words, if you plug in negative x for x, you get the same thing you started with. Let me give you an example. F of x is equal to x squared plus 1. If you plug in negative x for x, like this, simplify it, you get x squared plus 1. Is that the same as the original? Yeah, so therefore it's even. Okay, what about an odd function? How about, oh, and by the way, even functions are always symmetric about the y-axis. Odd function is a function such that f of negative x equals negative f of x. In other words, if you plug in negative x for x, you get the opposite of what you started with. For example, like that. If you plug in negative x for x, like this, woohoo, hopefully after a while you can just do it in your head. Simplify that. Okay, is that the same as the original function?
No.
Is it the opposite of the original function? Yes, so therefore it's odd. And an odd function will always be symmetric about that, about the x-axis. Well, let's think about that. If a graph is symmetric about the x-axis, like that, it's not a function. What? No, an odd function is symmetric about the origin. Just like y equal x cubed, see? You guys know what symmetric about the origin is? If you have a point, there's a difference between line symmetry and point symmetry. You guys learned this in geometry, right? Symmetric about a line, symmetric about a point. Symmetric about the origin means you have a point here, then you get the same point Basically, 180-degree rotational symmetry. Yeah.
So, it's not the opposite of the whole equation.
Yeah, it is. Opposite means you multiply it by -1. That's what opposite means, right?
Yeah,
Like, what's the
yeah,
opposite of 5?
So,
Let's see, multiplied by -1.
so if you just
-5.
f of negative x equals x cubed plus 1, and then,
Okay. So if f of x is equal to x cubed plus 1, how do you determine if this is odd, even, or neither? Plug in -x for x. Simplified. Is this the same as the original?
No.
Is it the opposite of the original?
No.
so you
No, so
only,
it's
you only
neither.
negate the x part, you don't
No, you
negate
negate the whole thing.
But then, shouldn't that be negative?
That's not.
No, but it's
No,
not.
when you're comparing the negative function, that's the best
Like
way
if
to
somebody
get it.
were to ask you, what's the opposite of this? It would be negative, you just multiply the whole thing by -1. Is that the same thing as that? No, so that's why it's neither. It's neither even nor odd.
Oh,
Alright. And everybody back up 1 foot again. You guys are good. Look how close you guys are. The first desk is supposed to be like over here. Strike 1! Okay, now we know what odd and people. See, this is part of the problem. You guys don't, you guys, last year, you guys just memorized stuff, and then now you're paying for it. You gotta learn how it all works. We're gonna use it the whole year, you know. We're not just gonna remember it for one chapter and it's gone. Like the binomial theorem, some of you still struggling to memorize it. Some of us still have it wrong. What's gonna happen when we keep using it over and over? Oh, just keep getting it wrong every time. Okay, well, if that's what you want. Okay, how do you find domain? What do you do? Okay, let me give you an example. I'll give you an easy one. X plus 1 over x minus 2. How do you find the domain of this? First of all, okay, wait. Do you guys even know the difference between domain and range? The domain is the set of all x values on a graph. And the range is the set of all the y coordinates on a graph, right? Okay, so what's the domain here? What numbers can I plug in for x? Any number except 2. So basically, when you have a fraction, you just got to make sure that the denominator is not 0. So how do you write that though? Because by definition, domain is a set. It's the set of all the x coordinates on a particular graph. So what?
Curly line.
Curly line.
Scratch it.
X such that x cannot equal 2.
Curly
You can
line.
write it like that. Curly line. It's called set. And you said curly line?
Yeah.
You were trained in this on Meet 1, remember? Curly line. I'll give you a curly line. Or if you rather write interval notation, negative infinity comma 2 union 2 to infinity. Everything except 2. Easy, huh? Okay, let's make it a little tougher. How about y equals the square root of 4 minus x squared? Okay, but before we even go on, this is a graph you're supposed to know. I'm telling you right now, this graph comes up a lot in pre-calculus and calculus. You should, just like when you see a parabola, you should know it's a parabola already, right? Like this graph, you see it, you know it's a
It's a
what's this?
flat line.
Yeah, it's like.
Flat line.
No, it's not against flat.
Well, if it was just square root of x, y equals square root of x, come on, that's a base graph that was on the inside cover of my book, right? It looks like that. But this is square root of 4 minus x squared. It's totally different. It's a semicircle.
Okay.
What? Semi what? It's a semicircle centered at the origin, radius 2. Look. Oh gosh. Let me ask. Okay, square both sides.
Y squared is equal to 4.
Okay, bring the x squared on this side, so you get x squared plus y squared equal 4. Hey, that's a circle. radius 2, centered at the origin. Yeah, but how come it's only a semicircle? Because it's the positive square root, so it's the upper half of the circle. If you had a minus there, then that would be the lower half of the circle. Because remember, we're only graphing functions here, right? The whole circle is not a function. But see, if you go backwards, see, if you're solving for y, if you went from this step to this step, you would have a plus or minus in the front there. The plus 1 is the upper half, the minus 1 is the bottom half. Put them together, you get the whole circle. Okay, so whenever you see this, you gotta just know it's a semicircle. So if you see that, the graph looks like this. Wakapo, 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 wakapo. Semicircle, radius 2, centered at the origin. Okay, anyway, well actually now you know what the graph is. What's the domain? Look, what's the list of all the x coordinates on this graph? What's the smallest x coordinate? What's the biggest x coordinate? And do you have everything in between? Yeah, so the domain is going to be from -2 to 2. Well, that's because you know what the graph is, but what happens when I give you something where you don't know what the graph is? Then you better have something you can rely on. Whenever you have a square root function, the inside of the radical has to be greater than or equal to 0. Because you cannot, if you square root a negative number, you're going to get imaginary things, right? But we're only working with real numbers here. So whenever you see a square root, the inside got to be greater than or equal to 0. This, okay, I can guarantee you this one's going to be on the quiz, except it's going to be something different inside the radical. It doesn't matter. Whatever's in the radical, you make it greater than or equal to 0. You get 1 point for writing that down. You want the other couple points? Solve it. Do we know how to solve inequalities? Yes, we just finished that chapter, right? So what's the procedure for solving inequalities? Make one side 0.
Get rid of squares.
Factor this side. And then
Graph on
make a number line. We just did this chapter. What goes on the number line? -2 and 2. Yes, yes. Plus, minus, plus? No, moose breath. Minus, plus, minus, because the leading coefficient is negative. So if you were to graph this, it's a parabola opening down, below, above, below. Or how about just plug in a number? Think of a number bigger than 2, like 3. 2 plus 3 is positive. 2 minus 3 is negative. Positive times negative is negative. And they're going to alternate because you got odd powers, right? Yeah, because some of you on one of the problems yesterday got the signs all wrong. Because the leading coefficient was negative. You guys put plus, minus, plus. It's supposed to be minus, plus, minus. And we want greater than or equal to 0, so we shade in the plus. See how we're using solving inequalities in this chapter? You can be doing plenty of this. So the domain is between -2 and 2, inclusive. That's how you find domain. How do you find range? Okay, so to find domain, this is the procedure. You solve for y and look for restrictions on what x can be. If it's a fraction, you just make sure the denominator is not 0. If it's a square root or an even root, then you just make sure the inside is greater than or equal to 0. But how do you find range? In fact, here, right here. Y, let's do the same problem. Now, if you knew how to graph this, it would be easy. Does anybody remember how to graph rational functions? That's the next chapter, by the way. This is the kind with the vertical and the horizontal asymptotes. Asymptotes? What's that?
Oh, the huggers.
If you don't know, what the what?
The axis huggers.
I'm afraid to even ask who taught you that. Huh? The dotted line.
I kind of wondered if the graph approaches like this.
Oh gosh. You can touch an asymptote.
Oh yeah.
Really?
Like it approaches the
Okay, you guys are warm, but still not close to hot. Anyway, okay, so I'm done. Next chapter, you got to look at that. This would be like an appetizer of the graphs you're supposed to be able to graph. Okay, but right now, okay, we don't know how to graph this. How do you find the range? Well, to find the domain, you solve for y. So to find the range, you would solve for x. So how do you solve for x in this equation? What would you do?
Cross multiply.
Cross multiply. We're solving for x now.
Get x's on
Put all the x's on one side, put everything else on the other.
Then factor.
Factor out the x. And then divide. So x equals, that means you're going to have to do some algebra, people. That's basically what has to happen here. There you go, you solve for x. And then now look for restrictions. Well, you have a fraction. Just make sure the denominator cannot be 0. So what makes the bottom 0?
1.
So the range would be y such that
Y is not.
y cannot equal 1. So it's mechanical, people. To find the domain, you solve for y and look for restrictions on x. To find the range, you do the opposite. You solve for x and look for restrictions on y. Doesn't that just make sense, though? Woo! Okay, what else you gotta know tonight? Domain, range, let me see the problems. I wanna make sure I cover everything. Oh, we gotta do piecewise function. In fact, you know what? Maybe I should do some of your problems for you. No! Yes. No. No. Silence.
10 of them.
Okay, okay, two more things we gotta cover. Absolute value, and then the difference quotient. That should be familiar to you.
Yeah.
Because I know your teachers, and not just Algebra 2 honors, 2A and 2B, they do a lot of difference quotient problems. Difference quotient, does that sound familiar? What? What? We're in trouble, as usual. See, last chapter was the chapter you're supposed to boost your average, but then that didn't happen. So now, with only one thing left in the quarter, now you gotta do it. This is not that
Wait,
easy.
do we have a
'cause-
test before the quarter?
we're not gonna have a test. So we're probably gonna have a maxi quiz Friday and an ultra maxi quiz next Tuesday. Whatever that means. 'Cause- yeah. You know why we didn't get there? Because homecoming came before, that's why. Because when we're in homecoming, we're in homecoming mode, right, remember? So we're only going slowly, so that's why we got slowed down.
When we're in
But now
homecoming
you can-
mode,
what-
do we
what?
go, when we're in homecoming mode, do we go as slow as regular?
No, regularly, come on. They're like babies. They're not even out of the womb. They're like just in the fetal position. At least some of us, at least the head is poking out. And some of you are like crawling. Oh, some of you almost starting to walk, but not quite. Okay, what are you doing now? What did I say?
Difference quotient.
No, absolute value.
Oh.
Okay, I'm gonna do a problem for you. It looks big, very, okay, look at your homework. Doesn't this look like one of your homework problems? It look almost like it. Look at it. Look at problem 6B. If anybody puts 6B on the board tomorrow, I'm gonna be very upset. Anyway, if you're doing your homework and you go, oh man, I can't do it, you know what you should do? Look at the examples. Do you guys even do that? Some of you still don't even know what the examples there are. Okay, what do you do when you see absolute value in a function? What should I do? A, pretend it's not there. B, change it to plus or minus. C, skip to the next problem. D, make a piecewise function.
D.
Okay, there you go. Didn't we learn last chapter that absolute value is a piecewise function?
Yeah.
So whenever you see absolute, and you gotta do this when you go to calculus. Whenever you see absolute value, you make a piecewise function. Okay, now, what are the pieces? No, what are the two pieces? X is gonna be,
Positive. Greater than 0.
okay, no, here's the absolute value. What makes the inside of the absolute value 0? 2. So like if you're doing the number line method, wouldn't you put 2 on the number line? Okay, so the two pieces are gonna be x is greater than or equal to 2 and x is less than 2. It's kind of like you make a number line, you got this side and you got that side, right? Except in this problem, x cannot equal 2. How come? Because it's in the denominator, cannot be 0. Now how does absolute value work again? If the inside is positive, you leave it alone. If the inside is negative, you negate it. Right? That's how absolute value works. So, if x is bigger than 2, is the inside positive or negative? Positive, so you leave it alone. Just this part now. You leave it alone. But if x is less than 2, then the inside is what? So you use this one, you negate it. We're doing exactly the same thing we did last chapter. Oh, I forgot everything from the last chapter, Mr. Park. Oh, now you're in trouble again then, aren't you? There you go. Well, Mr. Park, I don't know how to graph these things. Yes, you do. If you
Factor.
simplify it, you do. Look, that can be factored. X plus 2, x minus 2. Oh, the x minus 2's cancel. So what are you left with then? People, I am not going to give you something that you don't know how to graph. Like right now, you know how to graph lines, parabolas, and any polynomial function, right?
Yes.
Okay, what about this one? You can factor that as x plus 2 times x minus 2. This cancels that. What are you left with?
Negative x plus.
Negative x plus 2, which is a line. These are two lines. Okay, so whenever you see absolute value, you make a piecewise function. That's automatic. Okay, now you got a graph. You're lucky. This is a line. Like on tonight's homework, the first two are lines, and then you got a parabola for the third one. Woohoo! Well, actually, two parabolas. Okay, here we go. Now, are you guys good at graphing piecewise functions? How good are you? Okay, watch what I do. This, okay, let me ask you this. You're in a Turkish prison. The only way you can get out is by graphing this. What would you do? Just start plotting points. No, watch what I do. Okay, notice that it's 2, right? 2, here's 2. Plug 2 into here. What do you get?
4.
1, 2, 3, 4. So here's the point 2 comma 4. How come I put open circle?
Because it can't.
Okay, and then what's the slope of that line? What's the slope?
1.
1. So, okay, plug 2 into this piece. You get negative 4. What's the slope of the line? Negative 1. Right, isn't that the fastest way to graph a line? Plot a point and then put in the slope, right? I just put the point that's right on the edge there, so it's easy to do. So that's what a piecewise function looks like. Oh gosh. Alrighty then. Okay, and then the last thing on tonight's homework is you gotta be able to handle the difference quotient. F of x plus h minus f of x all over h. This is called the, well, there's lots of difference quotients, but this is the one all of calculus is based on. That's the reason why in your Algebra 2 book and in every Algebra 2 book and pre-calculus book, they make you do the difference quotient because all of calculus is based on this right here. You have to be able to work with this. So I'm going to give you a function. You have to be able to form this difference quotient and then simplify it. Okay, let's do one. F of x is equal to x cubed, period. Find this, the difference quotient. A, just stare at it. B, skip to the next problem. D, work it out. Okay, let's break it up into pieces. Look at this. F of x plus h, what does that mean? Oh gosh, okay. Let's go back even further. If this is f of x, how would you compute f of 2? So whatever's in the parentheses you plug in. Okay? So I plug in 2, you get 2 cubed, which is 8. Okay, now it's not a number, all hell breaks loose. Apparently. So, f of x plus h. Whatever's inside the parentheses, that's what you plug in for x. So, what do I see in the parentheses? So, what do you think I'm going to do? Plug that in for x. So you get x plus h cubed
Okay.
minus f of x. F of x is given, it's x cubed. And then you just divide the whole critter by h. That's the difference quotient, yes.
Is this the one that always simplifies?
Yeah. Oh, you're starting to remember things from last year. It's coming back like a bad dream. This is like period 3, there's just no response. Can everybody form this difference quotient?
Yeah.
Because if you can't form it, it's fatal error. Right? Okay, now simplify it.
X cubed plus.
Okay, x plus h cubed. How do you expand that? We just studied the binomial theorem, people. This should be second nature. I can put 10th power there and you can do it. Saving now for the test. Okay, what is x plus h cubed?
X cubed plus 3x squared h plus 3x h squared.
Very good. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, right? Or how about Pascal's triangle, which is the same thing. Minus x cubed all over h. And like Yamamoto said, the thing would simplify.
Yamamoto.
I think it's Yamada.
No, yeah, but but Yamamoto is my imaginary friend over there. Right, Yamada?
Yeah.
Anyway, this cancels this. And then can I simplify any more?
Yeah.
Yeah, you factor out h on the top. You get 3x squared plus 3xh plus h squared all over h. The h's cancel out. Final answer, survey says 3x squared plus 3xh plus h squared. Box that, that's the answer. Yes, it always simplifies nicely. Well, if you think that's nice. That's pretty nice actually, considering where you started from. So the key is you have to write down the difference quotient correctly. Let me see what kind of difference quotient problems you got tonight. Oh, oh, you only got one, number 10. No, it's at number 7. Okay, what time is it? Oh, what about number 9? Okay, I will do one of your problems for you then on number 9. Here you go. I'm not. Okay, let's do B. X squared over, no, what was the problem? X squared minus y squared equal 4. What, if I were to graph this, what is the graph going to be? Oh gosh, please help me. If that was a plus sign, it would be a circle, but it's not a plus sign. We learned this last year.
Half circle.
Hyperbola.
What's the difference between that and a parabola?
There's two of them.
Okay.
See what happens when you just memorize stuff and purge? Okay, now, if I ask you to graph this by hand, no problem, right? Let's review. You need. Remember, you want the side to be 1? To put it in standard form? How do you make the side 1? Divide by 4 and subtract 3 from both sides. I don't know, some people always subtract 3. But that doesn't put it in standard form. Let's review how to graph a hyperbola. This is a squared, that's b squared. Does that sound familiar? This number tells you how much to, okay, the center is at 0, 0. This number tells you to go 2 to the right and 2 to the left. This number tells you to go 2 to the up and then 2 to the down. And then you make the box. Remember the box? Well, if this was an ellipse, if that was a plus sign, then you just go whoop and then finish, right? But then it's not. It's a minus sign, it's a hyperbola. You make the rectangular box and then you draw in the diagonals. What is this? These are the hip huggers. What do you call them? You said something huggers. I don't want to ever hear that again. That's like,
The axis huggers.
well, it doesn't look like axis hugger to me.
Oh.
You guys just. Okay, now, if the x squared is positive and the y squared is negative, is this hyperbola left and right, or is it up and down? The 50-50 chance. It's left and right. See, you guys just memorize stuff. Whereas if you learn it, like if you learned it properly, then you would go, oh, the x-intercepts are plus or minus 2, right? Why are you covering that? Because to find x-intercept, you substitute 0 for y. Look, if you substitute 0 for y, don't you get x squared equal 4, x equal plus or minus 2? So the x-intercepts are plus or minus 2. What are the y-intercepts? Why are you covering up the left? So you get y squared equal -4. Yeah, there are no real y-intercepts, so there's no y-intercepts. So therefore, doesn't it have to go left and right? If it has x-intercepts but no y-intercepts? See, isn't that better than just memorizing? Oh, if the x comes first, it's left and right. If the y comes first, up and down. Okay, but now, okay, we know how to graph that, but graph it on your calculator now. Now remembering, okay, take out your calculator. Your calculator can only graph functions. Mr. Park, this is not a function. Yeah, try to press y equal. So what you have to do is you have to take this equation and solve for y. That's why in the directions it says solve for y. How do you solve for y in this? Y squared equals gosh,
X squared minus
x squared minus 4. Square root both sides, y equals, okay, square root both sides. Okay,
X plus 2,
let's
X
do
minus
the official way. What is the square root of y squared?
Y.
No.
Absolute value.
Absolute value of y is the square root of x squared minus 4. Therefore, y equals, if absolute value of x equals a, that means what?
positive or negative.
Y equals plus or minus the square root of x squared minus 4. But remember, I keep telling you guys, teachers leave out this step, so that's why a lot of teachers think that's that. I mean, a lot of students think that's that, and that's that, but that's wrong. This plus or minus comes from the absolute value. I keep telling you guys that. Maybe you'll learn it by the end of the year. Mr. Park, where's the plus or minus button? There is no plus or minus button. So when you graph this on your calculator, you gotta graph it separately. Y1 is equal to the square root of x squared minus 4. This will graph the upper half of the graph. And then y2 is negative square root of x squared minus 4. And this will graph the lower half. You put them together, you get the whole thing. Okay, try graph that. Why don't we do a zoom decimal? Zoom decimal probably look nice. Oh, whatever, zoom standard, whatever. This took way longer than expected.
Got it.
So does this mean we're using our calculator on Friday's Maxi quiz? Yes, most definitely.
Oh.
Most definitely. Okay, let me see what it looks like. Hey, it's a hyperbola! Let me see a Casio. Who's got Casio? This side of the room got Casio? Hey, it's a hyperbola! And I still don't understand what happened with that calculator.
That's good.
Okay, did we all get it? Oh, how come you get different colors? How come that Casio down there was all blue, but now you got the upper half is blue and the lower half is red? Oh, that's because on the Casio you can change the colors, right?
Mine has blue and red.
Say what?
Why is not working?
Oh, you can you change the color? Or it just automatically does different colors? No, I think you can change it, yeah. Except I don't know how.
Could you repeat?
Is that like Yamaguchi's one? You gotta reset it maybe.
I already did.
That's what she did, and she always gets something bad. Reset. Okay, what time is it? Oh my goodness.